This is Physical Science 2, Chapter 20, Part 1 on Earth Materials. In this portion of the video lecture, we will be discussing minerals. When we take a look at the composition of both the oceanic and continental crust on Earth, we see that the most common elements that are in the Earth's crust are oxygen and silicon. We talked previously in Chapter 12 about how a lot of the crust and mantle were composed of what were called silicate minerals. So we will be becoming more familiar with those in today's video cast. So what is a mineral? In order for a substance to be considered a mineral, you have to say yes to all of these four parts of the definition of a mineral. A mineral needs to be naturally occurring. So it must be found in nature. It cannot be man-made or synthetic. On the QVC and the home shopping channels and the like, they sell a lot of jewelry that are made from synthetic or man-made stones, the diamondique jewelry and the like. Those would not be considered minerals because they are made and created in a lab. Mineral must also be inorganic, so it needs to be made out of inorganic elements. It has to be solid. There are no naturally occurring liquid minerals. And all minerals need to have what we call a crystalline structure. A crystalline structure in science. Crystal just means a repeated pattern of atoms that are found over and over and over again. So a mineral needs to be naturally occurring, inorganic, solid, and have a crystalline structure. There's many different physical properties of each type of mineral, and the arrangement of atoms is very important in minerals. That determines the type of mineral and the characteristics that it has. There are some minerals that have the same types of atoms in their crystalline structure, but they are arranged in a different manner. There are also many minerals that have similar characteristics, but because of that atomic arrangement, they can be identified in different ways. We'll go through some characteristics here of minerals and talk about some different aspects of how minerals break, for example. There's two ways that a mineral can break. If a mineral, when it breaks, it creates a very smooth, flat surface. We call that an example of cleavage. Cleave meaning to cut, like a giant butcher's meat cleaver. So a smooth, flat surface creates cleavage, and you can have cleavage in more than one direction. So that is another characteristic of how we can define some minerals. If a mineral doesn't cleave, it will just break or fracture. So a fracture is a very uneven break or jagged. On the left side there of the diagram, we have an example of what's called conchoidal fracture, because it's a circular type of fracture, almost like somebody took an ice cream scoop out of the mineral, whereas on the right side, you get kind of a normal type of splintered fracture where you get a lot of jagged edges. The level of hardness in a mineral is also another way to identify it. We define hardness as a mineral's resistance to scratching, so its durability, if you will. We can use a scale that was developed by a German mineralogist, Friedrich Mohs. The Mohs scale is a hardness test using minerals that are of a known hardness, and you can use those 10 minerals to compare with an unknown sample that you have. So the Mohs scale goes from 1 to 10, 1 being very soft and 10 being the hardest mineral available out in nature. So when we take a look at the Mohs scale, talc, for example, that's found in talcum powder. That mineral is very soft. You could scratch it with your fingernails. Gypsum is often found in drywall, the components of drywall. Taking a look a little further down the way, quartz and topaz are a little more durable elements. They have a little harder resistance. And mineral number 10 on the list is a diamond. So when we use the Mohs scale, if I had an unknown sample and I had a topaz and I scratched it with a topaz and the mineral would scratch, that means that that mineral has less than a hardness of 8. If I were to scratch it with a feldspar and the feldspar became scratched by the unknown sample, then I would know that my level of hardness is somewhere between around a 7 or an 8. If a Mohs kit is not available, many mineralogists and geologists use a field version of this kit with a lot of common objects. A nail, for example, is around a 5 or a 6. A steel file is considered around a 7. A penny is considered around a 3 on the Mohs scale. Glass is about a 5 or a 6. And ceramic is considered around an 8 on the Mohs scale. So you can use these common objects to roughly see where on the Mohs scale of hardness your unknown sample is. Another way that we can identify minerals is how they reflect light, which is what we call luster. There's 2 categories of luster. We can have metallic types of luster or non-metallic types of luster. Some examples of non-metallic types of luster. We can say that a rock or a mineral rather appears kind of greasy on the outside. The middle diagram there is a good example of that. Another type of non-metallic luster would be waxy or glassy. The very right side image there, we would consider that an earthy type of luster because it resembles kind of the Earth's soil. Metallic types of luster, these are going to reflect light. So minerals that have a metallic luster, we can call that shiny, or in some cases for gemstones, we call a very metallic type of luster brilliant. We can also take a look of a mineral color, not just on the outside, but once the outside surface is scratched away, revealing what's called the streak of a mineral. The streak is the color of a mineral in powdered form. In some cases, the color of the streak can be a very different color than the actual surface of the mineral. As minerals weather and erode, as they're exposed to elements, their outside surface color can change. So it's important to take a streak test to see what the color of the mineral is in powdered form. Also, some types of minerals have a very unique type of streak. For example, the mineral hematite, which has a lot of iron in it, has a very kind of red-brown, almost cherry cola looking like streak, whereas the mineral itself is often looks very dark and almost black looking. So streak can be another way that we can identify colors of minerals as well. Another type of way to identify minerals is taking a look at the internal arrangement of atoms, the crystal shape of a mineral. So the atomic arrangement, remember, is very important to minerals. It determines the type of crystal shapes, and there's 6 total shapes in the crystal family, and some minerals are identified by their crystal shape. When we take a look at where do minerals come from, if they're natural, how does the Earth create its own minerals? Mineral formation is linked to atom arrangement, temperature of the magma or lava that these minerals form from, also the pressure of the environment that the minerals will form in. So minerals can come from very mineral-rich hot water, chemical processes like precipitation, or physical processes like evaporation, or the cooling off of magma can form minerals. So let's talk about the different mineral groups. The most common type of mineral groups is the silicate minerals. Remember, we have that as being composed of most of the mantle as well as the lithosphere, or the crust of Earth. So silicon and oxygen form a base unit that we call a silica tetrahedron. A tetrahedron has 4 sides. It is kind of a pyramid shape. And this is why silicon and oxygen are the 2 most common elements found in the Earth's crust and mantle. So we can have different types of silicate minerals. They can have this tetrahedron in a single structure like the mineral olivine. We can take a look at chaining these silicate tetrahedrons together. We can make sheets out of them to form the different mica minerals. And we can also put them into 3-dimensional networks for more complex silicate structure minerals like feldspar and quartz. So the minerals of the continental crust. Continental crust is very light in color and light in density, and there is a reason for that. That is because quartz and feldspar are the 2 most common silicate minerals that are found in the continental crust. Oceanic crust, on the other hand, is a little bit darker in color and it's a little bit heavier in density. So pyroxene and olivine are very common minerals that are found in Earth's oceanic crust. Basically, if you are not a silicate mineral, we categorize these minerals as non-silicates. The carbonates, which have carbon as a main element in these minerals, not all types of carbon are organic. There are substances in which carbon is found in that are considered organic, so don't get that confused with the organic forms of carbon. Oxides, of course, oxygen being a very important element that's found in an oxide. Halides, these are the salts. Sulfides and sulfates, these are minerals that contain sulfur as a main element. And the native metals of copper and iron and gold and silver, for example, are found in the non-silicate group. So we have no tetrahedrons in the non-silicates. Minerals are very important to us on a lot of different levels. Minerals are in many of our building materials. We mine them for economic purposes. And of course, the aesthetic quality of gemstones are made into jewelry. This has been Physical Science 2, Chapter 20, Part 1 on Earth Materials.